Hello everybody, this is Naya from DoSpace, and this is part 2 of the history of computer programming. So let's get started. Now the second program behind Fortran was COBOL. Although the first program was good at handling numbers, it wasn't so good at handling input and output, which mattered mostly when it comes to business computing. When it started to take off in around 1959, and because of this, COBOL was developed. It was designed from the ground up as a language for businessmen. Its only data types were numbers and strings of text. It also allowed for these to be grouped into arrays and records, so that data could be tracked and organized better. It is interesting to note that COBOL is a program COBOL program is built in a way similar to an essay, with 4 or 5 major sections that build into one elegant whole. And their statements also have a very English-like grammar, making it quite easy to learn. So computer programs had to do essays as well. All these features were designed to make it easier for the average business to learn and to adopt. Now the third program is called Lisp. In 1958, John McCarthy of MIT created Lisp processing, or Lisp language. It was designed as an artificial intelligence or AI research. Because it was designed for a specific deal, the original release of Lisp had a unique syntax. Essentially, none. Programmers wrote the code in parse trees, which are usually a compiler-generated intermediary between the higher syntax, such as C or Java, and the lower level code. Another obvious difference between this language in its original form and other languages is that the basic and only type of data is the list. In the mid-60s, Lisp acquired other data types. A list is, say that 3 times fast, is denoted by a sequence of items enclosed by parentheses. Lisp programs themselves are written as a series of lists, so that lists have the unique quality to modify itself and hence grow on its own. The Lisp syntax, known as Cambridge Polish, as it was very well different standard from different standard Boolean logic, which, as you can see here, this little geometry, and Lisp remains today in use because of its highly specialized and abstract nature. Now the next one we will be talking about is Algol language. The Algol language was created by a scientific committee for use in 1958. Its major contributions is being the root of the tree that has led to such languages as Pascal, C, C++, and Java. It was also the first language with a formal grammar known as Bacchus Nar form, or B and F. Though Algol implements some novel concepts such as recursive calling of functions, the next version of the language, Algol 68, became bloated and difficult to use. So it pretty much had a Windows Vista kind of thing going on there as well. This led to the adoption of smaller and more compact languages such as Pascal. Pascal was begun in 1968 by Nicholas Wirth. Its development was mainly out of necessity for a good teaching tool. In the beginning, the language designers had no hope for it to enjoy widespread adoption. Instead, they had concentrated on developing good tools for teaching, such as a debugger and editing systems, and support for common early microprocessor machines, which were in use in teaching institutions. Pascal was designed in a very orderly approach. It combined many of the best features of the languages it used at the time, which were COBOL, Fortran, and Algol. While doing so, many of the irregularities and oddball statements of these languages were cleared up, which helped which helped it gain users. The combination of features, input and output, and solid mathematical features made it a highly successful language. Pascal was also improved the pointer data type, a very powerful feature of any language that implements it. It also added the case statement that allowed instructions to branch like a tree in such a manner as you see here, and the case statement is also what you see in JavaScript. And now, C language. Pascal also helped the development of dynamic variables, which could be created while a program is running through the new and dispose commands. However, Pascal did not implement dynamic arrays or groups of variables, which proved to be needed and eventually led to its downfall. However, Worth created a successor to Pascal, Modula 2, but by the time it appeared, C was gaining popularity and gaining users at a rapid pace. So Pascal was put to the wayside, sadly. Ritchie developed C for the new Unix system, which we had talked about earlier in another video, the history of Unix being created at the same time as this. Because of this, C and Unix go hand in hand. Unix gives C such advanced features such as dynamic variables, multitasking, interrupt handling, forking, and strong low-level input-output. Because of this, C is very commonly used to program operating systems such as Linux, Unix, Windows, and Mac. In the late 70s and early 80s, a new program method was being created. It was known as Object-Oriented Programming, or OOP. Objects are pieces of data that can be packaged and manipulated by the programmer. Barney Straptrup, sorry if I mispronounced that, liked this method and developed extensions to C known as C with classes. This set of extensions was developed into the fully featured language known as C++, which was released in 1983. C++ was designed to organize the raw power of C using OOP, but maintain the speed of C and be able to run on many different types of computers. C++ is most often used in simulators such as video games. And it also provides an elegant way to manipulate and track hundreds of instances of people in elevators or armies filled with different soldiers. It is a language of choice in today's AP computer science courses. And now, the one you've been waiting for, kind of, Java. In the early 1990s, interactive TV was the technology of the future. Sun Microsystems decided that interactive TV needed a special portable, can run on many types of machines language. This language eventually became Java. In 1994, the Java project team changed their focus to the web, which had become the cool thing after interactive TV had failed. Well, of course it was the 90s, and such technology was too advanced back then, so go figure. It was kind of think of it as the portable Sega Genesis, if anybody remembers that. It was competing against the Game Boy, but while it had better graphics and stuff, it still was a bit too far in the future. The next year, Netscape licensed Java for the use of their internet browser navigator. At this point, Java became the language of the future, and several companies announced applications that would be written in Java, none of which came into use, however. Though Java has very lofty goals and is a textbook example of good language, it may be called the language that wasn't. It had serious optimization problems, meaning that programs written in it run very slowly. And Sun had hurt Java's acceptance by engaging in political battles with Microsoft. But Java may wind up as the instructional language of tomorrow, as it is truly object-oriented and implements advanced technologies such as true portability of codes and garbage collection. So whenever you look at your smartphone, you can somewhat thank Java for that. And now Visual Basic. Visual Basic is often taught as a first programming language today, as it is based on the BASIC language developed in 1964 by John Kermany and Thomas Kurtz. It's a very limited language and was designed for non-computer science people. Statements are chiefly run sequentially, but program control can change them based on if, then, and go substatements, which execute a certain block of code and then return to the original point in the program's flow. Microsoft has extended BASIC in its Visual Basic product. The heart of Visual Basic is the form, or a blank window, on which you can drag and drop components such as menus, pictures, and slide bars. These items are known as widgets. Widgets have properties such as its color and events such as clicks and double clicks, and are central to building any user interface in any language today. VB is often used today to create quick and simple interfaces with other Microsoft products such as Excel and Access without needing a lot of code, though it is possible to create full applications on it. Now Perl has been often described as the duct tape of the internet because it is most often used as the engine for a web interface or its scripts that modify configuration files. It has very strong matching functions, which makes it ideal for these tasks. It was developed by Larry Wall in 1987 because the Unix seed and awk tools used for text manipulation were no longer strong enough to support his needs. Depending on who you ask, Perl stands for Practical Extraction and Reporting Language, or Pathologically Eclectic Rubbish Listener. And now the future. Programming languages may have been underdeveloped for years and will remain so for many years to come. As you can see, they got their start with a list of steps to wire a computer to perform a task. These steps eventually found their way and began to acquire new and better features. The first major languages were characterized by the simple fact that they were intended for one purpose and one purpose only, while the languages of today are different by the way of how they were programmed, the way they were programmed in, as they can be used for almost any and every purpose. And perhaps the language of tomorrow will be more natural with the invention of quantum and bionicle computers. And so that is our presentation, the history of computer programming. If you'd like to learn more, please click on this website, and there will be a PDF with this presentation. So this has been Naya from DoSpace, and thank you for listening, and I'll talk to you later. Bye.